Let's revise LSTM. LSTM means long short term memory. L stands for long, S stands for short, TM means term memory. Why do we need LSTMs? Because RNNs are failing to remember the longer sequences. As the number of words are increasing, the data is lost in vanishing gradient. Previously we discussed about a example where we have 1000 words which talks good about a movie, and at the last 10 words that of that review was talking bad about that movie, and our RNN is telling that the review is bad. So this is not correct, right? The RNN is failing to memorize the long term memory in our data. So to tackle with that issue, LSTM was created. Previously we know that in RNN we have one input, and also we have another OT minus 1 which comes from previous iteration. Whereas in LSTM we have three inputs. One is our word, the other one is HT, hidden state from previous time step, and another one is cell state from previous time step. So what is this CT minus 1 and HT minus 1? The CT is called cell state. Cell state means long term memory. HT means hidden state. This hidden state is concerned about the short term memory. So we are essentially feeding the current word, the short term memory and the long term memory to process the information. Let's get deep into the LSTM. So in LSTM we basically have three gates. The first gate is forget gate. The main point of forget gate is that it will decide what information which is present in the long term memory will stay. That is the whole point of forget gate. So in our forget gate we will be sending our hidden state from previous time step and also current word. These two words will are basically vectors, numerical vectors. And these two words are concatenated together. If two lines are joining, it means concatenation. These two words are concatenated, and this concatenated vector is fed into a fully connected ANN network which has sigmoid as activation function. And here I have took three output neurons. That's why there are three outputs, O1, O2 and O3. These three outputs, will be present in the vector. This vector is called FT. It's called FT because this is a forget gate. That's why we named it as FT. And this FT is multiplied with the CT minus 1. CT minus 1 is the long term memory. This is multiplied element wise. Matlab O1 into 4, O2 into 5 and O3 into 6. That's how it's multiplied. Okay. Then let's go to input gate. The whole point of input gate is it will decide how much new information to add into the long term memory. Okay. So currently in our long term memory, CT minus 1 into FT is running. Okay. Keeping that aside, here we are having this concatenator vector, right? This concatenator vector is fed into two fully connected layers which consist of sigmoid and tanh. This is one separate fully connected layer and this is separate fully connected layer. Since we are having sigmoid, we will get one output. We are having tanh, we will get another output. And the number of neurons in this both will be equal to the number which we used in forget gate. Since in the forget gate we used three outputs, Here also we need to take 3 output neurons only. That is the rule. The vector which is coming from sigmoid fully connected layer is called IT, importance vector, and the vector which is coming from tan H is called candidate state. That's why we are representing with same C, but it is having tilde at the top of it. That could be the possible cell state. And these two vectors we are multiplying element wise. We will multiply element wise and add into the cell state. So our existing cell state, this we are adding with this. This is the current cell state. After that we have update gate. So the whole point of update gate is that how much information in our cell state should we send as a hidden state to the next time step. So we have CT, right? This CT, right? This CT is sent into a tan H. It means let's say CT is a vector which is having 1, 2, 3. Then tan H is applied on 1, 2 and 3. That vector is present here. That vector is multiplied with, we have this concatenated vector, right? That is sent into a sigmoid fully connected layer, and we will get one output, right? O1, O2 and O3. That is multiplied with tan H of CT, and that will become the new hidden state. Khatam.